Okay, so some of the exponentials that we can deal with might not necessarily be just a straightforward one. So sometimes we can get some exponentials that can be reduced to quadratics with the substitution. And so we're going to jump straight into an example and see exactly that. So what we're going to do is we're going to use the substitution u is equal to 3 to the power of x to solve the equation 9 to the power of x minus 7 times 3 to the x plus 10. So to solve an equation like this, we're going to start off by, what I do is just rewrite the equation down because I'm weird like that. I don't know, I just think I like having it so I can go down. Now, I want all my exponential terms to be dealing with, or will be in the form of 3 to the power of x, okay? So this 9 to the power of x at the front is not really helping me at this point in time. So what I'm going to do is I'm going to actually change it a bit. So I know that 9 is the same as 3 squared. So I'm going to rewrite this like this, okay? Now we know that 3 squared to the power of the x is the same as 3 to the 2x, which is also the same as 3 to the x times 2, which is the same as 3 to the x squared, like this. So what I can do is I can rewrite this as 3 to the x to the power of 2 minus 7 times 3 to the x plus 10, and that is equal to 0. Okay, so now that I've done that, and that little sort of algebraic gymnastics to get there, okay, what I'm going to do is I'm now going to apply the substitution. U is equal to 3 to the power of x. Okay, so wherever I see a 3 to the power of x, I'm going to replace it with u, and then alternatively change it back once I get further along. So 3 to the power of x is going to change to u, so I'm going to get u squared minus 7 times u, which is just 7u, plus 10 is equal to 0. Now, if you just saw that, you'd say, oh, that's just a quadratic equation. We know how to solve those. And the first thing to solve a quadratic is you're going to have to factorize it. So to factorize this, we're going to go, well, what are two numbers that multiply to give 10, but add to give negative 7? So we'd have to go through all multiples. Negative 10 and negative 1, negative 5 and negative 2, and then the same, but vice versa. We can see from these, we get negative 5 and negative 2 as our two solutions. So in this case, u has to be equal to 5, and u has to be equal to 2. But we're not asked to find what u is equal to. We're trying to find what x is equal to. Now, we used the substitution before u is equal to 3x, and we can interchange at any time, okay? Because we're just using u as basically a placeholder for the 3 to the power of x, okay? We don't have to use 3 to the power, we don't have to use u at any point, okay? We can always just replace it back with 3 to the power of x. It's just kind of like a placeholder saying, I know that 3 to the power of x is here, I'm just going to use something else to make the algebra a bit nicer to work with, okay? So at this point, we can then sub u is equal to 3 to the power of x back, and we're going to get 3 to the power of x is equal to 5, and 3 to the power of x is equal to 2. So just like with a regular quadratic, this one's going to give us two solutions as well. So 3 to the power of x is equal to 5, and 3 to the power of x is equal to 2. So again, we need to solve this using our change of base. So for the first one, which I'm going to call this one number 1, and this one number 2, okay? So for number 1, we get 3 to the power of x is equal to 5. So rearranging this, we get x is equal to the log base 3 of 5, okay? Now using that change of base, we've got log base 10 of 5 over log base 10 of 3, and so therefore x is equal to, and then we'll just put that in our calculator and get a solution. Now, we don't actually have to do any point from here onwards, okay? This answer here is more than enough. And in fact, you know what? Let's just leave it at that. Because we're trying to find the exact values that make the equation above true, okay? This is the value that makes that equation true. Now number 2, 3 to the power of x is equal to 2. Okay, rearranging it into logarithmic form, we get log x is equal to, okay, it's going to be log base 3 of 2, okay? And so that's our two solutions. So therefore, the solutions to, and it's 3 to, it was 9 to the power of x minus 7 times 3 to the x plus 10 is equal to 0 are when x is equal to log 3 of 5 and when x is equal to log 3 of 2. Okay, so just like a regular quadratic, we do have to answer the question, and you know, if I was to substitute those two values back into that equation at the top, the original equation that we began with, we would see that they would be equal to 0 regardless of which one we put in. So that's how we solve it with the quadratics. In the next one, we're going to be looking at some inequations.